students, it's day 2 for the chapter Sound. In previous lecture, we had discussed what are sound waves and reflection of sound waves. The specific objectives of today's topic are what is an echo, determination of speed of sound by the method of echo and use of echoes. Our first topic for today is what is an echo. Students, just see this picture. You can see a person standing at some distance from this hillside and producing a sharp sound. One can hear two distinct sounds when a person produces a sound. The first one is the original sound, which is heard almost at the same time, and the second sound heard after reflection from this hillside. You can see these blue lines. This shows the reflection of the sound which is heard after some time, and that second sound heard after the reflection is called an echo. So definition comes up as the sound heard after the reflection from a distant obstacle. Distant means a far away obstacle. The obstacle should be at least 17 meters away from the sound, from the source of sound. Then only an echo is produced. After the original sound has been ceased. Ceased means stopped. The second point says, the reflected sound, if heard along with the original sound, is not an echo. The sound which is mixed up with the original sound, the reflected sound which is mixed up with the original sound, that is not an echo. Now our next topic is conditions for hearing an echo. An echo is heard only if the distance of the person producing the sound or the source of sound from the rigid obstacle or reflector is far enough. The minimum distance between the source of sound and the reflector should be 17 meters. The second one is the size of the reflector. This is the reflector, and the size of the reflector must be large enough as comparative to the wavelength of sound waves. The sound which is being produced by the source of sound should be small as compared to the size of the reflector. The third says intensity of the sound should be such that the reflected sound reaching the ear is sufficiently loud to be audible. The sound should be loud enough so that it is audible to the other person. Now let's read the conditions. As already discussed, the minimum distance between the source of sound and the reflector in air must be 17 meters. The size of the reflector must be large enough as compared to wavelength of the sound wave. And third is the intensity of the sound should be such that the reflected sound reaching the air is sufficiently loud to be audible. That is, it should be loud enough so that a person can hear the sound. Now next topic is determination of speed of sound by the method of echo. Students, the echo method can be used to determine the speed of sound in air. For this, sound is produced from a place. Let's suppose sound is being produced from this place, this is the source of the sound, and this is reflector, and the distance between them, let's suppose it is d, and the sound is heard after time t, that is echo time or repeated sound is heard after the time t. Then speed of sound is calculated by distance upon time. Here distance will be taken as 2d. Why? Because sound has first travelled from this source of sound to the reflector and then it strikes again back. So the total distance is taken as d plus d, that is 2d, over time taken, that is t, which is the time for reflected sound. Now our next topic is use of echoes. The first one is sonar, which stands for sound navigation and ranging. The principle of sonar says that when ultrasonic waves are sent in the sea water in all directions from the transmitter which is fitted in the ship, these waves are received back by the transducer or receiver. After reflection, they get reflected from an obstacle, which can be an enemy submarine, an iceberg, a sunken ship, or seabed. And thus we can estimate the depth of the sea, or we can judge where is the enemy's submarine, or if any iceberg or any other obstacle is there, we can estimate the distance of that obstacle by using sonar. The second one is bats. Students, bats fly with the speed much lower than the speed of sound. The sounds produced by flying bats gets reflected from the obstacle in front of it. By hearing that echo, bats come to know that what is the location of that obstacle even in the dark. So they turn away from their path and fly safely without colliding with it. And this process of detecting an obstacle is called as sound ranging. The next application is use of echoes in medical field. Students, in medical field, echo method of ultrasonic waves is used for imaging human organs such as liver, gallbladder, ureters, womb, etc. And this is called as ultrasonography, in which ultrasonic waves are sent to human organs which get reflected back from the human organs, and if any fault is there, any stone is there, its image can be detected on the screen. A question arises, why ultrasonic waves for producing echoes? The answer for this is ultrasonic waves are more energetic than the audible sound, as the frequency of ultrasonic waves is above 20,000 Hz. So they have the following three properties for their wide use. The first one is they can travel undeviated through a long distance. They do not easily get deviated from their path. Second is they can be confined to a narrow beam. Confined means restricted. They can be restricted to a narrow beam. And third is they are not easily absorbed in a medium. So our topic for the day is completed. Thank you.